In this video here, we're going to take a look at an introduction to the normal distribution. The normal distribution is a continuous probability distribution, and it's arguably the most important probability distribution that we have. Now, it also has many applications in fields such as finance and economics, medical research, and academia and assessments. So to begin with here, what I want to do is just discuss the shape of a normal distribution curve. And we can see an example here over on the right. So this is for the random variable x here, so let's just define x before we continue. So x is normally distributed. So notice here we use n to represent a normal distribution. And for a normal distribution here, we have two parameters. The first parameter here is the Greek letter mu. That represents the population mean, and we also have sigma squared. And sigma squared here represents the population variance. So let's just make a note of these below. So mu here, like we said, that's the population mean. That's the population mean. And then we have sigma squared here, which represents the population variance. Okay, so those are the two parameters here that we use for a normal distribution. Now, we haven't noted it here on the curve in the diagram, but this line here in the middle, this is actually the population mean. This is mu. Okay, so let's just add that on here. So this here is mu. Now, we also haven't added it onto the diagram here, but to the right here of mu and to the left here of mu, we're going to add 3 marks. Got one here, and say one here. And then again, 3 to the left now of mu. So one here, and finally one here. So these marks here, so to the right, that's an increase of 1 standard deviation for each mark. So this is going to be mu, it's going to be sigma plus mu. This one here would be mu plus 2 sigma. And this one here would be mu plus 3 sigma. Okay. And then similarly to the left here, this would be mu. So this first mark here would be mu minus sigma. This one here would be mu minus 2 sigma. And this one here would be mu minus 3 sigma. Okay. So we'll come back to why that's important. I want to give that kind of like the last property here for the normal distribution. But hopefully my next point here now seems quite intuitive. So the area here under this curve is equal to 1. And like I said, that should seem hopefully intuitive based on the law of total probability. Okay, so the area under the curve is equal to 1. I won't write this down, but like I said, hopefully that seems intuitive based on the law of total probability. So let's just note here some important properties for the normal distribution. So properties here for the normal distribution. Well, like we said, we have 2 parameters here, mu and sigma squared here. So 2 parameters. Let me just make a note here. So we have 2 parameters. Again, I won't define each one individually, but we have mu and sigma squared there as our 2 parameters. Okay. So like we also mentioned as well, the normal distribution here is symmetrical. So it's symmetrical here. In this case, it's symmetrical by the mean. And the reason for that is because the mean is equal to the median, and that's equal to the mode. Let's make a note of that here. Like we said, the mean is equal to the median, and that's equal to the mode. Okay. Now, again, I can't remember if we quite mentioned this, but for a normal distribution curve, it will often look like this bell-shaped curve here. Okay. And it might be a little bit wider, might be a little bit thinner, but it will always have that bell-shaped curve. Okay, so let's make a note of that here. So for a normal distribution curve, we always have bell-shaped curve. Okay, like we said, we also mentioned it up here, but I'll just also add it under the properties here. The area under the curve, like we said, is equal to 1. The area under the curve is equal to 1. So finally here, we're on to like the last properties here. Now, we're going to discuss this idea then of what we mentioned here about this being an increase of 1 standard deviation, 2 standard deviations, 3 standard deviations, and why that's important. So for a random variable, I'll just abbreviate this to r.v. So for a random variable that is normally distributed, then what we know here about the normal distribution is that approximately 68% of the data lies within 1 standard deviation. So approximately 68% of the data, lies within 1 standard deviation. Or S.D here, that just represents the standard deviation. What do we mean by that? Well, what we're saying here then, if I do this in a different color, so this is mu minus sigma here, and this is mu plus sigma, okay? Within this region here, what we're saying then, if I just kind of do a quick sketch here, again, won't be perfect. Let's just say that's my mark here. Like I said, my scale isn't perfect here, but between mu minus sigma here and mu plus sigma, we've got 68% of the data here. Okay, so I'll just sketch that in. This here is approximately 68% of the data. Okay, so in orange here, this is 1 standard deviation. 1 standard deviation, like I said, that's approximately 68% of the data. So now let's do it in a different color here. In fact, let me just make the note actually first. So now, for 2 standard deviations then, we know that approximately 95% of the data lies within 2 standard deviations. Approximately 95% of the data lies within 2 standard deviations. In fact, let me just do the last note here as well. And then for the last point here, we know that approximately 99.7% of the data, so pretty much all of the data here, that lies within 3 standard deviations. So we just cut to the chase here, then this lies within 3 standard deviations. Again, let's just kind of show this here on the curve. So let's do the second one here in red. This would be mu minus 2 sigma, and this here would be mu plus 2 sigma. And what we're saying here then, between these 2 points, we know that approximately 95% of the data lies within these 2 points here. So if I was to kind of sketch over here, that would be approximately 95% of the data. Again, if I just kind of show this here, let's do it underneath. So from this point here to this point here, that is 2 standard deviations. That would be approximately 95% of the data. And then finally, let's do the last one here in blue. From here now, this point here to this point here, so this would be mu minus 3 sigma. This here would be mu plus 3 sigma. Then between these 2 points here, like we said, we know pretty much all of the data lies between these 2 points. And again, I would just kind of shade over that point there from here. Okay, so like we said, these last 2 points here, this is for 3 standard deviations, and like we said, is approximately 99.7%. And I hope that, again, that should seem quite intuitive, not particularly the numbers as such, but the idea that obviously if we increase the standard deviations, we're capturing more of the data. Okay, so 1 standard deviation, approximately 68%, 2 standard deviations, approximately 95% of the data, and then finally for 3 standard deviations here, that's pretty much all of the data, so approximately 99.7% there. Okay, And there we have it. So that brings us into this video. Like I said, this was quite an info heavy video. There's no questions as such for this video, but there is quite a lot to take in. So do take a note of everything that we've got here, the properties, how we define a random variable that's normally distributed, and this idea here behind the shape of a normal distribution curve. Okay, but there we have it. So like we said, that brings us into this video on an introduction to the normal distribution.